So how does this work? So you can see here on the right, I've got this TwinCAT project structure. Every single element in that is defined as what we call a tree item. Okay, and this is necessary for the demonstration I'm going to give. I'll show you in LabVIEW in a minute as to why what this is. But every single one of these elements, whether it's a system, the real-time node, a PLC program, doesn't matter, is a tree item in the TwinCAT project. That's how the structure works. So if you think of it literally like the old search menus on Nokia phones, when you go into contacts, go into a particular contact, find the email address or whatever, and that sort of drop-down menu style, that's exactly how TwinCAT works in the background. Okay. And the automation interface essentially gives you a lot of functions that allow you to navigate to any one of those tree items and perform operations on it. So, for example, you can navigate to the I/O option. So TwinCAT I/O at the bottom here, add an EtherCAT master. Navigate to the PLC node, add a PLC. Navigate to the particular task, in this case, the PLC task, set a new cycle time. Yeah, if that makes sense. So it's a very easy to understand system to operate, that then becomes quite gives you quite a lot of flexibility, because you can go right down to even adding in new bits of PLC code. So you can actually go in and modify programs on a machine should you wish to, yeah, and remote deploy them. So a lot of companies use it for that capacity. DLL itself is free. You can just it comes with a TwinCAT install. Currently, it needs Visual Studio and TwinCAT installed on the same machine to operate. So when I show you the demonstration in a minute, you'll notice that as well as LabVIEW, I've got Visual Studio and TwinCAT installed on the same virtual machine. Okay, that in the next version is going to be changed. So in the next release of TwinCAT that's coming out, hopefully in towards Q3 this year, that limitation will go away. So you won't actually need Visual Studio or TwinCAT to do this. You could just do it with a LabVIEW install and nothing else. Okay. And if you're interested in, there's a link to where it is, and you can read the description and give you a much more detailed version of what I've just said, if you really want to. So the first test for me was, can I pull a DLL into LabVIEW, which I hadn't ever done before. I've always just used the libraries that exist in there. It turns out you can, which was quite useful. And what I ended up finding was I was having to, basically, I have a project that I share on GitHub that I've done all this stuff in C# and made my own little wrapper that works the way I want it to work, and it works for me. And I found myself recreating the entire thing in LabVIEW. So I stopped doing that and then took the DLL from my project in C# and brought that into LabVIEW to start the process of going through what I was trying to achieve. The only thing I discovered is the version of LabVIEW I'm using, which is 2021, is still .NET framework based. So I had to rewrite or recompile my DLL for the .NET framework rather than .NET 5 or 6, is what the other one is on. But yes, so all this is a very simple set of classes that wrap up all that functionality. So I have a method, for example, that says add an EtherCAT master, and it automatically navigates to the I/O and adds an EtherCAT master on that tree item. Things like that. So nothing particularly complicated. Okay, so all that makes sense so far. Good. So now we enter the bit of this where it's all going to go horribly wrong, because I'm going to try and do this for you live. Okay, here we go. If it all goes peak on, I'll just throw this bottle of water, a glass of water on my laptop and run away. So this is a virtual machine that I've got on my laptop. And in here is where I've been creating these VIs. I've been trying to recreate the functionality of the automation interface in LabVIEW directly. I started quite simply. I have a set of sub VIs in here that do a lot of the stuff. So, for example, if I open up this particular one here, there's nothing particularly special about it, but all it does is activate a TwinCAT project on a hardware target. Okay, I found some nice easy shortcuts which were quite useful. So for adding these things in, like the constructor node, for those who haven't done adding DLLs into LabVIEW, it's actually quite simple. It opens up its own little interface which allows you to navigate through the DLL you've added. In this case, my one is just called the framework. So I add that, and then inside my engine class, that's where all the C# code lives effectively. So I've got my IO handler class here, so I can do all the EtherCAT stuff, my PLC for modifying PLC code, the TwinCAT handler for doing system setup and so on. And essentially, once you've got that, it's just a case of importing a particular class and then adding in these invoke nodes, which then connect to the class you've output and give you the ability to use methods from that class. So you can see here, this is my TwinCAT handler. So in here, I've got the ability to activate solutions. I can create tasks. I can create mappings, isolate cores, and a few other bits and pieces that I will show you. Now I've done all that, it's going to break my thing, but never mind.
Has this BM got hardware connected to it? Or is it
So yeah, so I've got both basically. So I have in our office in Henley, I have one of our IPCs connected up. So you will be able to see an actual live bit of hardware being pulled into the system. So I created a set of base VIs that just allow me to implement the C# code that I had created in LabVIEW. So I went through the process of creating the icons, trying to give it some form of uniformity so it actually made sense what I was actually trying to do. And the first one that I created, this one. So this is a really, really simple little demonstration VI. All it does is make the very first C# program that I wrote in my GitHub repository. It will create a project, a TwinCAT project, connect it to a particular target, so a particular piece of Beckhoff hardware. It will then scan in to see if it can detect any of the IO connected to it, and it will then save the Visual Studio project. That's all it's doing. Okay, so if I was to open up the create VI, we can see in here, I've got a constructor creating an instance of my Visual Studio handler, passing that in. I have to do this process called initialize the Visual Studio environment, which basically means it looks on my laptop for what versions of Visual Studio I've got, and then uses the appropriate one that's installed. After that, it's very simple: create directory, create solution, and then create my TwinCAT project. Not to maximize that. The next one is a very simple block that just does a thing called setting the target. Now, Beckhoff systems communicate via a system called ADS. And when I'm talking about setting a target, that's what I mean. So it's actually not looking at my local laptop. It will look at the thing that it's being connected to via ADS. So if I run that, hopefully, if this doesn't all fall over very quickly, what should happen is Visual Studio pop up. You can see the TwinCAT project then appearing on the right. And what it will then hopefully go and do, if it doesn't fail like it does, is of course, always going to do it under live, isn't it? This is literally tested just under Canteen earlier. It's the annoying thing. Bear me 2 seconds. Pardon?
Would be a demo if it would.
Like I said, it's one of those irritating things that where like it literally worked 10 minutes ago. This was the first one I got working, and I was so proud of it as well. I was like, yes. Now it's letting me down. So, sorry, go on. No, so I'm just using some very simple inputs into this. So all I'm doing is giving it a project file, which is just a location on my desktop where I wanted to create it and a name. The target net ID, as I said, is based off the ADS system, which is what we use to communicate. And then I'm basically giving it a name for the EtherCAT master. Just make sure you are. Which bit's erroring out. The other thing I found that was quite interesting was when I did this was it was actually a better thing to not have the not have all the wrappings I'd done in my .NET side of things to protect errors popping out, because actually it was easier to understand them in the LabVIEW environment than it was in the C# one, which I thought was quite interesting. How it's working now. There you go. It was because I already had the project that I created at lunchtime sat in there, and that was what was annoying it. So you can see here how it's worked fantastically. The TwinCAT project's being created on the right here in Visual Studio 2019, and all it's done is, after scanning the I/O network, it has imported all the pathways, all of the I/O that's been added in. Okay, so this looks like a very confusing mess of stuff here, but it's actually rather simple if you think about it like that nested tree structure. So everything comes off this TIID device 1, which you can see here on the EtherCAT master is what I named it. So that is the name of the EtherCAT master, which you can see here. So there's device 1. Underneath that, I have my EtherCAT image. A bit bigger so you can see it better. With some terminals on it, and there's a lot of different sub-terminals you can see here. So if I offer that up against what the LabVIEW puts in, so you can then see a correspondence here. Device 1, underneath box 1 CU1128, which is basically an EtherCAT switch that exists in this network. I've then got a term EK1100, which is the first one. On here, I've got a 9227, a 6900, a 2904, and so on. And you can see the map being built up here. Okay. What this lets me do, or the benefit of doing this, is in a TwinCAT system, when you want to actually run a project, you need to bring in the I/O and then put the system into run. But what this does is bring all of these objects back into LabVIEW so we can then manipulate them from LabVIEW. Okay, so now I know all these pathways. I can create links between I/O. I can create links to the PLC if I was going to have a bit of PLC running. I can change the terminals or change the setup internally of the terminals if I wanted to. But to be honest, when this worked the first time and I just saw the list of I/O pop up, I cheered a little bit. So that's the first little demonstration. I'll show you inside what's actually happening. As I said, there's the first one that just creates the project, and you won't have noticed, but at the top here, I have I/O station appearing up here. So that would have shown as local if I'd have opened this from a blank template. That set remote target is what changed that from pointing at my local virtual machine to pointing at the system in Henley. And just to give you an idea of so you can see how quick that was realistically, I'm running this LabVIEW and TwinCAT on a virtual machine, which is running TeamViewer over VPN into an IPC in our office in Henley. So it's not too bad. Okay.
Over our Wi-Fi.
Over your Wi-Fi, yeah. The guest Wi-Fi as well, not the good one as well. Yeah. Yeah, I'm probably in trouble, aren't I?
That's fine.
Okay. No one's cut it off yet, so. This one is a bit more difficult. So this one is the one that actually does the scan of the EtherCAT network. Okay. So in here, I create a object called IO handler, which is as I said, the base object I created in C#, which does the scanning. And in here, I've created this method scan IO, which actually does quite a lot. Essentially, in a TwinCAT system, you can look at all the devices on it. So you can look at the USB ports, you can look at RJ45 ports, you can look at PCI slots. That scan IO looks at all of that. Technically, it's a cheat because it then finds the EtherCAT network and only adds that one. Okay. But what it then does is it pulls out all of the then found IO into this array, which is what then populates that array on the front panel. So quite a simple one, hopefully. If I wanted to, I could then actually run this system. So I actually reload devices, put it into free run. I could then see data being exchanged live on the terminals. So you can see the voltages. So this particular terminal I'm on is a fuse module. So you can see that it's currently got 24 volts sat across it. Things like that. Get rid of that now. I shall delete this. Cool. So that was the first one. I then slowly built up from that, and then ended up creating one which actually did very similar things. So it actually does a lot of the first steps, which is to create the project, connect to the remote target. But this one actually then creates a task inside TwinCAT, and TwinCAT needs a task to run anything. Okay, so all this one really does is create a task and then define a set of process tags that will appear on that task. Because the goal of this one was to automatically set up a project that would then run on the target that could then be got at by the ADS system inside LabVIEW. Hopefully this doesn't completely die on me. So this one's running through the same process. You can see there's a little busy bar that keeps happening at the bottom of Visual Studio. That's it, doing the actual scan of the IO network and bringing in and populating that. Once this one's finished, it should then, what it will actually do is then create a link between a task that's created and the always licensing. So for those of you that haven't used TwinCAT, it has a 7-day rolling trial license that you can just keep activating. That's free. So if you ever have any issues with it, you can just activate the trial license. So what this effectively did then was create a just a dummy variable that I can use to actually communicate with the IO system. And it would have stopped when it got to the, unfortunately stopped when it got to the licensing issue, but that's not. And it will basically allow me to then run this project on the remote target. So I've now got a task running, which is actually running all the IO at 10 millisecond rate. Hopefully, yeah, it did all that, good. What that should then allow me to do is introduce another set of tests that I was messing around with, which is actually the ability to then read and write in and out of that system. So we have a ADS library that exists that we created that allows us to pull ADS data in and out of a TwinCAT real-time system. So the automation interface allows you to control it, set it into run and make it go. The ADS then allows you to communicate with it. Now it's going to inject me for the trial license locally. Hold on. So what this one is going to let me do, hopefully, is actually explore that image and then pull in data. So you can see here, I've now got the information coming in from those devices, and I can then access any of that, should I wish to, directly in the, might ping me for a license in a second. Bit of license on it. Again, as I said, you can just activate trial license as you need to. Two on those ones that would be nice if I'd have done that downstairs instead of eating lunch. But I got carried away. Sorry, everyone. So all I've done is activate the, like I said, a local trial license to allow me to run this interface. on the system itself. And my VM's frozen.
Chris, that creation of that task in that last bit you ran is the bit that enables you then to access it via that library that you guys have developed. Is that right?
Yeah, so the thing that the automation interface thing allows me to basically parameterize an entire TwinCAT system. I would like to do that, so I can do everything from so yeah, it allows me to create the image, scan in the IO, and add in a task that then lets me run the IO. So TwinCAT works by having a task associated, so it always needs a cycle time to run at, right? So whether that's a 10 millisecond cycle time or a 20 millisecond cycle time or even a 100 microsecond cycle time, it doesn't really matter. But it needs a time reference at which it's going to actually run.
From my understanding, the automation interface is letting you actually configure and program that hardware system, whereas the ADS interface is talking to a hardware system which has already been established.
Exactly.
So there's sort of levels of integration you can do with LabVIEW where if someone doesn't want to do all the configuration and putting that hardware task in, they could hand that off to someone else who's just working with that system and talk over ADS. If they want to reprogram on the fly through a LabVIEW, then they can do that as well with the automation interface.
Exactly.
Yeah, I'm just sort of cycling back because I've looked at Beckhoff, but I haven't really done much with it.
That's right. There's time. So, but yeah, essentially, you can, like I said at the start, you can do everything from completely ignore this because you don't want to touch it, to splitting out into different teams that have different goals in terms of what they're actually trying to achieve in terms of the development of it. So you can have people that are specifically there to do PLC development. You can have people that are there to do deployment tools. You can have people that are there to handle data acquisition, analytics and things like that. So it depends how you want to split up. And these two systems combined allow you to do all of that effectively. You can either completely do it manually in TwinCAT or with LabVIEW and just pass data backwards and forwards as like CSV files and all that sort of stuff, or you can have live data exchange and then have a tool in LabVIEW like I want to create here that makes it completely valuable what's actually running on the other end. It's entirely up to you effectively and what you guys want to do with it. As I said, it's an incredibly open system. So everything that you can do in TwinCAT can be automated through the automation interface. So literally everything you could set up in TwinCAT in terms of code, IO settings, field buses, or whatever you like, licensing, everything you can automate in the automation interface, and therefore you could do in LabVIEW should you wish to. So it then becomes a question of what do you want to give people the ability to do. You know,
what do you want to experiment? Do you want to make a black box, or do you want to make something that can be played?
Exactly. So we have customers that will do things like they actually will create a sort of like a GUI front end that essentially allows the customer, essentially allows their machine assemblers, because that's what they are at this point, they're not doing any programming as such, to go on, open this GUI up and select, oh, okay, we're building this machine, it's got this variant, this variant, this variant on it. The automation stays in the background that they program, then deploys that to the target PC. And that's it. It completely removes, the people that are doing this, they're not even aware that TwinCAT or Beckhoff are even involved at that point. It's just a GUI interface that opens up. Yeah, or you can make that entirely remote. So this one is then the ADS side of things. So I've shown you that bit of data earlier where you've got the voltages coming in from my little fuse module at the top here. See those two voltages coming in and out. So all I've done is using the communication version of this. I've added those into LabVIEW and I can then see that being exchanged here as well. Yeah. That makes sense. So there are a load of samples that exist for doing this. So if I open this one for sake of argument, so you could find examples. There you go. So there are a load of examples that get installed with TwinCAT that do give you the some sample code for how you do this reading and writing. So you've got for example, a very simple read here, or what they refer to as a simple read, which when I first opened it looked insane to me. But it basically runs a single browser, initializes the ADS communication, and then pulls in data in a constant loop. I then simplified it to this, because this hurt my brain less, which is very simple anyway, which does the exact same thing. Okay, so this reads a string from a target. I have an initialization block here, which is what you use at the start of every ADS communication backwards and forwards between LabVIEW and TwinCAT. This is what actually tells LabVIEW what it's trying to talk to. And it follows this string format here. So you can see in this particular case, I saved it as a standard bit of data. It's actually talking to a string variable in my main program called main name, which is a string 80. It's given a data size of 648 bits, and it's located at this particular net ID, so the ADS address and this particular port. So that init will happen every single time you open up an ADS communication. Okay, so initialize that variable. You then have the reading happening here, which can be synchronous or asynchronous, depending how you choose to do your programming, and then a marshalling of the data type from the TwinCAT data type to a LabVIEW version or backwards. And then I release at the end of it, just release that handle, so it does a single read. But that's basically all. This one, back to my example, it disappeared. Where that's all this one is doing, just more complicated, effectively. That one, the DAC, is basically a tool that we created that doesn't simplify that, but auto generates it for you, so you can see what's actually happening. So you run that, it opens up. I'll show you what it exactly does. So you can run this, open up this block, and it will basically recreate all that for you as an auto-generating tool that allows you then to communicate with what I just did. So this is the simple interface. That's what generates that text string that I showed you. So in here, I can click on this. It will then give me a navigator, so I can connect. So any TwinCAT target that's available on your network will appear here. Yeah, so I've got the local system, which is my desktop. I've then got these two routes which are saved, which don't exist anymore, and then the IO station, which I've been connecting to. So I can select my fuse module, pick a couple of inputs. So let's look at the load, voltage in, voltage out. Okay, that I can then set up some interesting things about data, where I want it to create controls indicators for me, which I do. I can then have it run for a particular period of time, should I wish to, and save the file out, but I'll just let it run continuously for a minute. And all I need to do is click OK, and off it goes and creates that that same structure effectively. So if you come down here, you'll see inside this, you've got the initialization block that I showed you a minute ago, and then inside here, all that other stuff's contained. So when I run this now, hopefully, you should then see zero load on it. But yeah, you can see the voltages expressed as tenths of volts, say 230 or 240 volts, then, or actually that's 24 volts. Reality. Does that all make sense?
Yeah.
Cool. As I said, this whole thing started off as just to see if you can make it work, but yeah, the automation interface works quite well. I'm not suggesting for a minute that you take my repository off GitHub and use that, because I'm sure I'll end up with comments going back about how rubbish the programming is. But you can take the raw DLL that comes with TwinCAT and use it yourself to create your own wrappers that are proper LabVIEW ones rather than my sort of half and halves at the moment. And then, like I say, you can then create a LabVIEW GUI that allows you to do what you like with a TwinCAT real-time system effectively.
Chris, in that example you gave where you had those, you said there's 3 different units that you could run, and selected it and it deployed the TwinCAT project accordingly.
Mm-hmm.
Presumably you could do that same thing in LabVIEW, right? So if you've got existing projects, the process of picking that up and
Yeah, so this one I created was a test to run it in a virtual machine, which I can try. So this one runs, effectively does the exact same thing as the others. It creates a project, but this one adds an existing PLC project that currently exists. You can see the file path for it here. And then tries to run that. So let's get rid of the old one.
Did you have to create the TwinCAT project in the first place, regardless of what you're doing?
No, you can create everything. You can have everything saved as templates, or you can create everything from scratch. The automation doesn't let you do either. So you can see the ones where I was scanning in IO. You can export the IO and just have it as a template. So you could have, say, for example, one of the main reasons that we created this originally was to handle sort of machine variants. So you can see that's now popping up an error on my desktop, but Visual Studio disappeared because what it's actually done is create a PLC project on my virtual machine and put it into run mode. So I'll quickly open up that. Why is it stuck here? Excellent. If I open up this project, now it will directly connect to my virtual machine. You'll see it running in there. But yes, the real reason we did it originally was to handle machine variations. So you have a machine that has 6 components, say, but the machine builder can deliver that in 1 or all 6 versions of it. That becomes a pain in the backside to do on a production line. So they basically saved an IO configuration for each variant and which went, we'll load that one in. And that comes back to the GUI I was talking about with the machine operator, which go, it's that one. Yeah, things like that. So you can literally create everything from scratch, or you can save it as templates. So this is the project it's just created. So it's opened up an existing PLC project, which I can then log in and look at. And you can see there's just bits of data being exchanged here. So I haven't activated any configuration. I haven't done anything with that. The automation interface deployed that directly. One of the little tricks that I had to learn for doing this particular one, there's a block here that I haven't talked about. Virtual machines, you have to run inside a virtual machine, you have to run TwinCAT on an isolated core. So what this block actually does is set in TwinCAT, or sets on the virtual machine, an isolated core, and then assigns the task to a different core as well. So you can be very specific about what's using the Windows operating system, what's not, where TwinCAT actually runs. So you can set up all. So just gives you a bit more of a clue that all the functionality available to you is available through the automation interface, and you can stick that all in LabVIEW. As it turned out, there's some complicated stuff I haven't tried yet, which is next on my list, which is to set up a servo drive and tune it via LabVIEW. That's my next one. But yeah, I was quite happy when I got these ones working, to be honest. Yeah. Okay.
Any questions from the online guys?
To go to. Want to stop sharing?
Yeah, we can
switch over.
Ian, you were up next. You want to?
I'm up next.
Share your one.
So you want to do on yours, so I can drop out of the meeting.
Yeah.
Yeah. Okay. To avoid.
So I need to do something a little bit fancier this time because I'm showing.
Just one up and shoot.
No.
That's what's going on.